Hi friends, I'm Abhinava Akash from Symbiosis Institution of Technology, BTech. Now I'm at third semester and today's topic is Kruskals Algorithm. This topic was given by our professor Dr. Piyush Shawn. Now we learn about Kruskals Algorithm and minimum spanning tree and the core principles and its step-by-step initialization and the code and entirely. So it is a cornerstone in the world of data algorithm. It is an elegant tackles the challenges of finding the minimum spanning tree within a connected undefined graph. So you can see the core principles of the Kruskals algorithm. First, greedy approach and disjoint sets, edge sorting, cycle prevention. In greedy approach, at each step, it chooses the edge with the smallest weights and make sure it doesn't create a cycle. And disjoint sets. Uh, This data allows for the fast operation like finding the sets at particular vertex and merging of two sets. It is a very useful disjoint set and edge sorting. First, it's arrange the entire list in the ascending order and sorts it so that it enables the affection selection and cycle prevention. The core of the algorithm lies in preventing cycles from forming in the MST. MST stands for minimum spanning tree. And if you can see the step-by-step illustration, building the MST. First, you need to initialize and then edge selection, then it will be cycle detection and MST. In initialization, it starts with an empty uh, set and the empty disjoint set structure. All these verticals have a separate components. In edge selection, first is sort list of the edges, then the it compares with the smallest weights so that it doesn't create a cycle and this edge is added to the MST. In this next step, cycle detection. Before adding an edge to the MST, the algorithm uses the disjoint set structure to check if the two verticals connected by the edge are already in the same connected component. If they are, adding the edge would create a cycle and edge will be discarded and MST completion. This algorithm continues selecting edges and merging components until all the vertices are connected. At this point, the MST is complete. It contains all the vertices and minimum possible total edge weight. And we can see the applications of the Kruskals algorithm. There are network design, transporting system, electrical circuits. In network designing, it finds a way into network design by helping the minimizing the cost of the connecting nodes in a network. For instance, it can be used to determine the optical conformation for cabling in a building or designing communication network. It helps a lot in transporting system, like aiding the optimization of the routes and minimizing the travel distance. It's valuable for planning route network, railway systems, and air travel routes. It also helps in electrical circuits. In electric circuit design, Kruskal assists in finding the most cost-effective way to connect the components in the circuit, minimizing the amount of wiring needs. This reduces the cost of material and improves the circuit effectively. Now we can there are sorting, disjoint sets, over complexity. Uh, for initial step of sorting, the edge has a time complexity of an E log E, where E is the number of edges. For disjoint sets, it is an inverse accompaniment function which grows extremely slow. For overall complexity, it is E log E for the graphical, which is the edge. Now you can see the simple pseudocode which is very helpful to understand the Kruskal's algorithm. Now at start we are initializing the MST as an empty set. You can see here initializing MST as an empty set and sorting all edges in G by their weights in non-descending order means in ascending order. Then you are initializing a disjoint sets in the data structure for each H, U, and V. In the sorted list, it will find the U and V are same or not. If they are belongs to a different set, then this MST will be added, and then it combines the set of U and V to one, and it will be returned to the MST. So guys, I hope you understand this Kruskal's algorithm. I tried my best. Thank you.